Hello and welcome to this presentation. We're going to factor a trinomial using factor by grouping. Why do we have to do this compared to the last video where we had a separate set of procedures? Well, the reason is because notice in this type of example we have a number on our leading term here. Our leading term is x squared. We have a 2 attached to it. I can't factor that 2 off because there's nothing common between any of these three terms. So we have no choice but to go this route of factoring. So step 1, and once again how you know to do these set of procedures is when there's a number on your leading term that you just can't get rid of. You can't factor it off. So step 1, you take the first term and the third term and you multiply them together. So 2 times 5 will give me 10. Step 2, you ask the riddle. You say what two numbers when multiplied together will give me 10, but when added or subtracted together will give me 11. Well, you have 10 and 1 or 5 times 2. Which one could either add or subtract to get you 11? This one does not. 5 and 2. No way you could combine those through addition or subtraction to get 11, but this 10 and 1 you can. So this next step is probably one of the more difficult steps, but it'll take some practice. As long as you kind of understand it, you could use that as a foundation to practice these types of problems, so hopefully you get better and better at it. Step 3 is we need to expand out our original problem, our 2x squared minus 11x plus 5, where the middle term is made up of our two factors. So I'll show you what I mean. So I'm going to take my 2x squared, which is the original first term of our trinomial here. So it'll be 2x squared minus 10x minus 1x plus 5. So this right here and this are exactly the same thing. All I did was I took my minus 11x and expanded it out to show or to be reflective of my factors of 10 and 1. So I set it up like this because minus 10x minus 1x will give me minus 11x. So now we look at the next step here, and that's called factor by grouping. Factor by grouping, this sub-step is pretty simple. You group the first two terms, you group the last two terms. So now we look at the first grouping, pretend the second grouping doesn't exist, and we look to see what's common between the two terms. So I'm going to expand this 2x squared out into 2 times x times x. I'm going to expand this 10x out into 2 times 5 times x. So comparing these two right here, I'm going to look to see what's the same that I can factor out. I have matching 2's, so I cross it off on the list. I have matching x's. I could cross them off on the list. So now there's nothing else that's in common, so I put back x minus 5 in parentheses. Now the goal with the second grouping is to get whatever I have to put back in parentheses to match exactly with what I have in parentheses from the first grouping. I need that what's in parentheses in the first grouping to match what's in parentheses of the second grouping. So look at what I have here, minus 1 plus 5. That's exact, minus 1x plus 5. That's exactly the opposite in sign of what I have in parentheses. So what I have to do is I have to factor out a minus 1 because that will change everything that I put back in parentheses. It'll change the sign of it. So minus 1x is now plus 1x. A plus 5 is now minus 5, all because I factored out a minus 1. A minus 1, when I distribute it, will change the sign of everything in parentheses. Now, you always want to do subchecks to make sure you're correct. Like, for instance, after I'm completed this factor by grouping, distribute the 2x to everything in parentheses to make sure you get right back to the original problem. And 2x times x is 2x squared. 2x times minus 5 is minus 10x. Minus 1 times x is minus 1x. Minus 1 times minus 5 is a positive 5. So we did everything properly. Now we have this and this. What is the same between the two set of terms that I underlined? That's an x minus 5. So because that's similar, I could cross it off on the list. What am I left with in parentheses? 2x minus 1. 2x minus 1. They're not common, so I have to put them back in parentheses. So this right here would be my final answer. And FOIL it. Make sure you get right back to what this is. If you do, then you did it right. If you don't, if after you FOIL this, it doesn't match your original problem, then you did something wrong and you'd have to try it again. So now let us try one more example with factor by grouping. I want to show another example so you could see how the steps are exactly the same. I'm not going to deviate from the steps that I just went over. So once again, notice with this trinomial, 4y squared plus 7y plus 3, that I have a 4 on my leading term. So you cannot use the logic fully in the prior video because there's a number on our leading term. And we can't factor it off because there's nothing common between these three terms. So we got to do our factor by grouping. Step 1, multiply the first and the third term together. 4 times 3 is 12. Step 2, we ask the riddle. What two numbers, when multiplied together, give me 12, but when added or subtracted together, give me 7? Well, what does 12 break down into? 12 times 1, 6 times 2, 4 times 3. Which combination of these gets me to 7 if I add them or subtract them? 4 times 3. 4 times 3 is 12. 4 plus 3 is 7. So now, step 3, we have to expand out our original trinomial so that our middle term is made up of our two factors. So to do that, 4y squared plus 4y plus 3y plus 3. Why did I set it up like this? Because 4 comes from our first factor, 3 comes from our second factor, and 4y plus 3y gives me 7y. So this and this are equal to each other. It's just that the middle factor is expanded out to be reflective of our two factors here that we asked in step 2 from the riddle. So now the next step is factor by grouping. Group the first two terms, group the last two terms. So now we ask what is common between these first two. And I'll just rewrite it here. I'll expand this out. 4 times y plus 4 times y. And we could assume this is all multiplied by 1. So what's common between this and this? A 4. Could cross it off on the list. A y. Could cross it off on the list. And I'm left with y plus 1. So now we have a second grouping to worry about. So I have plus 3y plus 3. We could assume this 3 here is multiplied by 1. So I compare this with this. What's common? What can I factor out? A plus 3. If I could factor out a plus 3, I could cross it off on the list. And there's nothing else common, so I'm left with y plus 1. And notice that what's left in parentheses from the first grouping and what's left in parentheses from the second grouping are the same. So now we compare the two. What's the same? A y plus 1. So I could cross it off on the list. And I'm left with 4y plus 3. And this would be your final answer. Remember, you could always FOIL this to make sure that you get right back to the original problem, and if you did, you are 100% correct. That concludes our discussion on factoring a trinomial by factoring by grouping. Thank you.